Hello, everybody. Here we are, Chapter 9. This is 9.1, Solving Systems by Substitution. And I think it's kind of interesting, I think. I think it can be also a little bit more versatile than graphing. I think we found this on some of the questions, I recall, a question about like volume of a bucket or something like that. Having to figure out or think about how to graph these like really big numbers and think about the scale can be a bit kind of clunky. And this is a way to kind of work around that. And so I think you might find it helpful. I put these notes in there for you, so you don't have to write it all out, but I would still kind of like to just kind of go over it. So steps to solve this system right here, these two equations, x minus 3y equals negative 10, and 3x plus 2x equals 14. So first we start by isolating a variable in one of your equations. So you could isolate the x, you could isolate the y. In this one, I chose to isolate the x. So we already had the x by itself with no coefficient. So you wanted to have no coefficient with it. I added 3y to each side. Let's see if it'll let me draw this. So I added 3y to each side to get a positive 3y subtract 10. And now what we're saying is that x equals 3y subtract 10. So what we can do with this information is put this in for our x. We can substitute it in there. We're saying this x is equal to 3y subtract 10. So substitute your value into the other equation. So now we have 3 times 3y subtract 10. We're saying this x is equal to that. And so we substitute it. That's our substitution step. And then our next step would be to distribute this inside. So we're going to go 3 times 3y and 3 times negative 10. So 3 times 3y is 9y, 3 times negative 10 is negative 30, and then we just have the rest of our equation as it is. That just kind of ports straight over. Then I use these little symbols to show I've kind of taken another step. What I've done is added our like terms. I added the 3y and the 2y together. That gave us 11y. And I moved this 30 over as a positive 30. So 30 plus 14 gives us 44. And then as our final step, I divided by 11 on each side, and now we have this idea that y equals 4. So we have a single digit that y equals, which is great. And now we can substitute it back. We can substitute it in either of our equations. We now know what y equals, and we can solve for x. So I chose this version of the equation. So I said x equals 3 times 4. We just figured out what y is. That's great. Minus 10. So y or x equals 3 times 4 is 12. 12 minus 10 equals 2. So now we also know what x equals. Great. And then our last bit is to check our answer. So is it true we have two equations? It should be true in either of these equations that our values work. So I use this one right here at the top. I use this equation. 3 times 2, our value for x, plus 2 times 4, our value for y, should equal 14. And is it true that 6 plus 8 equals 14? Yes, it is true. So those are basically the steps, or exactly the steps, and I'll show you some examples. So let's do one right here. Switch back to blue. So the following systems of linear equations, solve the following systems of linear equations by substitution and verify your answer. So we already have an isolated variable. It's got no coefficient, so that's wonderful. So we're going to substitute this information in for our y. So we're going to have 2x subtract 3 times negative 5x, don't forget the x part, plus 17 equals 0. So now we're going to use this information to solve for x. So let's do 2x. Negative 3 times negative 5x is going to give us positive 15x plus 17 equals 0. Now I want to get our numbers on one side. Let's subtract 17 from each side. And let's combine our like terms. So now we have that 17x, that's 2x plus 15 equals 17x, equals, this is gone now, that equals 0, and equals negative 17. And then let's divide by 17 on each side. And we get that x equals negative 1. So negative 17 divided by positive 17 gives us a negative 1. And so now we have a solution for x. We can choose which one we want to substitute it back into to solve for y. This one looks much simpler. I think I'll stick with that one. Y equals negative 5 times negative 1. Therefore, y equals, what's negative 5 times negative 1? That's just positive 5. So there you go. That's not so bad. And now we should verify our answer. Maybe let's use the other one just for the sake of it. Let's do 2 times negative 1, subtract 3 times 5 plus 17 should equal 0. And then let's check. Negative 2 subtract 15 plus 17 should equal 0. And I would say that that does. Negative 2 plus or subtract 15 is negative 17. Negative 17 plus 17 does equal 0. And you can confirm that we did those two correct. So our, solution for this, you could say x, y, if you want to do it as an ordered pair, negative 1, 5, but either of those solutions is fine. Okay, let's see what else we got. Let's do the next one. We already have our x isolated, so let's use that one. Why not? And let's substitute this whole thing in for our x in the other equation. So 4 times, 2y, subtract 20, plus y equals 1. And then let's FOIL, or if distribute, let's say, I guess not FOIL. Let's distribute that inside. 4 times 2y is 8y. 4 times negative 20 is negative 80. Plus y equals 1. Let's add 80 to each side. And let's combine our like terms. We got an 8y and a y. And we get 9y, that's 8y plus 1y, equals, we're adding 80 to each side, so 81. And then we can divide by 9 to get the y by itself, and y equals 9. 81 divided by 9 is 9. Okay, beautiful. And now we can solve, I suppose, using either of them. Let's do the one where the x is already by itself because we're solving for x. So let's do x equals 2. Now we're just substituting our value of y into this equation. 2 times 9, subtract 20. X equals 2 times 9 is 18, subtract 20. So x equals negative 2. So there's our other one. And our final step, let's just see, let's just confirm that we did this right. So let's do 4. You can use either of the equations. 4 times negative 2 plus 9 should equal 1. So is it true that negative 8 plus 9 equals 1? I would say that that is true. So I think we confirmed that we did it right. You could say, solution x equals negative 2, y equals 9, something like that. I don't know if I should write that plainly. Maybe I should. I kind of started to write it plainly up here. Solution x equals negative 1, y equals 5. Maybe that's helpful. Okay. So you see the steps. I would always confirm it. You can use either of the equations. Let's keep going on these ones. So you could isolate either of these. Neither of them have a coefficient, so you could subtract x from each side or subtract y from each side. Maybe let's subtract y from each side. Why not? So let's first subtract y, x equals negative y plus 9. And now let's input this into our x value. So negative 10 times negative y plus 9 plus 6y equals 6. So now we're solving for our y's. Let's distribute this negative 10 inside the brackets. So negative 10 times y gives us positive 10y, and negative 10 times 9 is negative 90. And then we just have this stuff left over, plus 6y equals 6. Now let's get all of our y's on one side and all of our numbers on the other. So plus 90 to each side. And let's combine our like terms. So we got a 6 there and a 10 there. So now we have 16y equals 96. Oh, I need a calculator for this. Let's do 96 divided by 16 equals 6. Show you that step. Divided by 16, divided by 16. Y equals 6. And now let's we can put y into either equation. The top one looks easiest. You can kind of see it's going to be 3. So let's do it anyways. Sure, x equals negative 6 plus 9. X equals negative 6 plus 9 is going to leave us with 3. And you can see, is it true if we substitute it in that 3 plus 6 equals 9? Is that true? I would say it is true that 9 equals 9. So there you go, you confirmed it. So maybe I should say here plainly, solution, x equals 3, y equals 6. Like that. Hello. I had to stop the recording because I realized on my example there shouldn't be a 2 here. So I actually think I might have taken it off already on your sheet. So hopefully there's no 2 there. I'll just blank it out. And yeah, it was resulting in some really, a strange answer. So let's do it this way. And then in fact, I think I will isolate that y that I just made with no coefficient. So maybe let's add y to each side. So we get 6x equals 20 plus y. And then let's subtract our 20 from each side. And we will get y equals 6x minus 20. And then now we have our y by itself. Let's substitute it into our other equation. So 2x plus 3 times 6x subtract 20 equals 20. And then let's distribute our 3 inside. We get now 2x plus 3 times 6 is 18x. Oh, sorry, I think I missed a 0 there. Yeah. 3 times negative 20 is negative 60, and that equals 20. And then let's add 60 to each side. And let's also combine our like terms. We've got x's here and x's here. So we have 20x, scroll, equals 80. And if we, divide by 20, we get that x equals 4. So 80 divided by 20 is 4. So our first of two solutions, hopefully, if I've done it right. And then we can substitute the x back into either of our equations. So why not? Let's do 2 times 4 plus 3y equals 20. 2 times 4 is 8 plus 3y equals 20. Let's subtract 8 from each side. And we get that 3y equals 12. And we can divide by 3, and we will get that y equals 12 divided by 3 is 4. So it looks like they're both 4. And our final step, let's verify our solution. Let's see, is it true that 6 times 4 subtract 4 equals 20? Okay, is that true? That is it. 24 subtract 4. Does that equal 20? I would say that it does. So our solution is x equals 4, y equals 4. Okay, I will let you know what textbook questions I'd like you to do. Thank you so much.